All right, let's talk about something that sounds like it's straight out of a sci-fi movie, but it's happening right now. We're diving into nanotechnology, the science of the unbelievably small, and I mean really small, and how it's about to change, well, pretty much everything. So let's just start with this, kind of a wild idea. What if we could build our world, literally, atom by atom? I mean, forget bricks, forget steel. Imagine grabbing individual atoms and arranging them just so, creating things we've never seen before. New medicines, impossible materials, a completely new future. That right there is the incredible promise of nanotechnology. Okay, so here's how we're going to break this down. First up, we'll figure out what nanotechnology actually is. Then we'll jump into how it's changing medicine in some amazing ways. After that, we'll look at how it's building a stronger, better world. And finally, we'll touch on the future, both the incredible promise and, yeah, some of the challenges too. All right, let's get right into it. The word nano can sound pretty intimidating, right? Super abstract. But don't worry, we're going to make this invisible world feel very, very real. So the official definition talks about working at the nanoscale, but what does that really mean? Well, think about it like this. For all of history, we've built things by taking big stuff and cutting it down, or melting it. With nanotechnology, we're doing the exact opposite. We're going down to the level of single atoms and molecules, the basic Legos of the universe, and we're telling them exactly where to go and what to build. It's a total game changer. Okay, to really get a grip on this, we have to talk about scale, and the numbers are just mind-bending. A nanometer is 1 billionth of a meter. That's a 1 with 9 zeros after it. It's a scale that's so small, our brains aren't really built to understand it. So let's try to put it into perspective. Okay, look at this. A single human hair, something we can barely see, is what, 80 to 100,000 nanometers wide? It's huge. A nanoparticle, the thing we're actually working with here, can be just a few nanometers across. We are talking about a world that is thousands of times smaller than the thinnest thing you can imagine. It's a completely different reality. And you know what? If that last comparison didn't quite land, this one will. Just try to picture this. If a single nanometer was the size of a marble in your hand, then 1 meter, about 3 feet, would be the size of the entire planet Earth. Let that sink in for a second. That's the scale we're talking about. And understanding that scale is the key to everything we're about to discuss. So, now that we have a sense of just how small nano is, let's see what we can do with it. And the first stop is one of the most important: medicine. We're talking about a genuine revolution in how we heal people. Okay, so here's a problem doctors have faced forever, especially with something like cancer. How do you kill the bad cells without destroying all the healthy cells around them? I mean, traditional treatments like chemo, they're powerful, for sure, but they're kind of like a bomb. They just carpet bomb an area and cause a lot of collateral damage. But what if you could use a sniper rifle instead? And that's exactly where nanotechnology comes in. Picture this. Scientists create these tiny, smart nanoparticles. Think of them like microscopic drones on a mission. You inject them into the body. They're engineered to completely ignore healthy cells. They just float right by. Their only mission, their only target, is to seek out and lock onto cancer cells. And once they've found their target, bam, they deliver a payload of medicine directly to the tumor, and only the tumor. So what you get is what people are calling precision medicine. It's that shift from the shotgun to the sniper. It's way more effective, it has way fewer devastating side effects, and it's a perfect example of how thinking really, really small can solve our absolute biggest problems. But healing is just one piece of the puzzle. It's not just about tiny delivery systems. See, that same principle, arranging atoms just the way you want them, can be used to build materials. And not just slightly better materials, we're talking about stuff with properties that sound like they belong in a superhero movie. I mean, just take a look at this. We've built our entire world on steel. It's strong, but man, it is heavy. Now, look at carbon nanotubes. All they are is a sheet of carbon atoms 1 atom thick, rolled up into a perfect little tube. And because of the way those atoms are bonded, this material is 100 times stronger than steel at just a tiny fraction of the weight. This isn't just a small step up, it's a whole new league. And this chart really just says it all, doesn't it? When engineers talk about materials, what they often care most about is the strength-to-weight ratio. And, well, you can see for yourself, it's not even a fair fight. The possibilities this opens up are just staggering. Think lighter, more fuel-efficient jets, or buildings that are stronger than anything we can build today. Now you might be thinking, okay, this is cool, but it sounds like it's decades away. Well, guess what? You're probably already using it. That sunscreen you put on, it uses nanoparticles to block UV rays. That fancy shirt that water just beads up on, yep, coated with a nano layer. Scratch-resistant glasses, stronger tennis rackets, lighter bikes. This stuff isn't the future, it's already here, hiding in plain sight. Okay, so we've seen how nanotechnology can heal us, how it can build a stronger world. It sounds incredible. But with any technology this powerful, this world-changing, you have to stop and ask some tough questions. It's not all upsides. And this really lays out the two sides of the coin. The promise, it's almost utopian. Curing diseases, limitless clean energy, clean water for everyone on the planet, it's all on the table. But then there's the peril. What are the long-term health effects of releasing these tiny particles into our bodies and our environment? What happens to economies when entire industries are disrupted? These are massive questions, and we have to be thoughtful about them. We have to balance that amazing potential with a serious sense of responsibility. And that brings us to the most important point of all, really, the big takeaway. For all of human history, we've basically worked with what nature gave us. We'd find wood or stone or ore, and we'd shape it. But now, for the first time ever, we're not just shaping matter. We are commanding it. We are learning to engineer our world from the atom up. That's a shift in power unlike anything we've ever seen before. So it really leaves us with this final, kind of profound thought. It seems like our biggest future is going to be built from our smallest parts. We are unlocking a power we're only just beginning to understand. So the real question isn't when is this coming? It's already here. The only question left is, are we ready?